So now we're really going to start getting into determinants. But remember, we've already talked about determinants a little bit. When we talked about the cross product, we used determinants to find the cross product. And when we talked about the inverse matrix, we used the determinant in the formula for an inverse matrix. The thing we really want to start with determinants is just this simple idea of a 2x2 determinant. So let's say we have the matrix A, and the matrix A is equal to A, B, C, D. These are our 4 entries. The formula for the determinant, first of all, we write the determinant either as the determinant of A or with these straight lines around A. And in the same way that we put straight lines around A, we can put straight lines around the matrix instead. So like this, A, B, C, D. So if you see a matrix with straight lines around it instead of bracketed lines like this means you have the determinant of this matrix instead of just the matrix itself. This specifically means determinant. And so all of these things are just equal to the value in the upper left multiplied by the value in the lower right. So A times D minus the value in the upper right times the value in the lower left. So B, C. Keep in mind that you can only take the determinant of square matrices. So the smallest one we're going to deal with is this 2x2 matrix. And the determinant of a 2x2 matrix is always this AD minus BC value. And this is critical to know because when we're given a 3x3 matrix and we have to find the determinant, we'll break the 3x3 determinant down into 2x2 determinants and then use this AD minus BC to calculate the 2x2 determinants. Or if we're given a 4x4 matrix and we need to find its determinant, we'll break the 4x4 down into 3x3s and then break all those 3x3s down into 2x2s. And then once we have the 2x2s, we'll use this AD minus BC. So everything kind of hinges on this value. Remember that if the determinant is equal to 0, so if the determinant of A is equal to 0, that tells you that the matrix is singular. It's not invertible. It does not have an inverse. But if the determinant of A is non-zero, if it does not equal 0, then the matrix is invertible. It has a defined inverse. You can find its inverse. So just so that we can remember how to calculate determinants, we've already looked at the 2x2 determinant. Let's do a quick example with a 3x3 determinant. So if we're asked to find the determinant of A, first of all, we would say the determinant of A is equal to, and then we would create a new matrix where we have straight lines instead of these bracketed lines. So -2, 3, and then 1, 1, 4. And this 3x3 determinant is going to break down into 2x2 determinants. So first, we're going to look at the entry in the first row and the first column, which is this 1 here. When we use this value, we want to ignore everything in the same row as 1 and everything in the same column as this 1, and only look at the values that are outside of the row and column of the 1. So when we start off here, we'll use the 1, and then we'll multiply that by this 2x2 determinant. So -2, 3, 1, 4. And then once that's done, we'll go to the next entry in the first row, which is this 0 right here. So we're going to look at the 0, and this time we again ignore everything in the same row and column as the 0. So only paying attention to what is outside of the same row and column as the 0 gives us these values right here. So when we break this part into a 2x2 determinant, we have the 0, and then we have 0, 3, 1, and 4. And then for the last part, again, we're going across the top row here. The last value in the top row is this 6 right here. And then ignoring everything else in the same row as the 6 and the same column as the 6, we only pay attention to this part here. So then the last 2x2 determinant is this 6, and then we have 0, -2, 1, and 1. Now the only other thing that we have to pay attention to here is the sign of these 3 determinants. We have to remember this checkerboard pattern. So let's go ahead and put up here, we have this checkerboard pattern for the determinant, and we always start with a positive sign in the upper left-hand corner, and then we alternate. So negative, positive, and we could keep going as far as we need to across the first row. Same thing down the first column. Starting with this positive, we go negative, positive, negative, positive, as far down as we need to. And then the rest of the pattern just fills out. So positive, negative, dot, 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 and then negative, positive, positive. And you could keep going as far as you need to sort of get this checkerboard pattern. And so when we look at how we broke down this 3 by 3 determinant, because we used the 1, that's going to be a positive sign according to our checkerboard. So we have a positive 1 here. The next sign, the sign for the 0, is a negative according to our checkerboard pattern. So we need a minus in front right there. And then the next value is going to be a positive. So we put a positive 6 here. Now keep in mind, if this 6 had instead been a negative 6, yes, we have the positive sign for the checkerboard pattern, but we have to say plus here out in front, plus, but then still negative 6. We have to pull the actual value. So we would have plus negative 6, which would turn into a minus 6. So my recommendation is always just to pull the actual values that we have and then go back to your checkerboard and assign signs in front of each of those terms. And if you have a double negative you need to cancel, you can do that. So then once we have this broken up, it's just as simple as calculating these 2 by 2 determinants. And we already know how to do that. So here we take negative 2 times 4 is a negative 8. 3 times 1 is 3, so minus 3. This second determinant here is multiplied by 0. So this whole determinant is going to cancel. We don't even have to calculate that value at all. So then we go down to this third one here and we get plus 6 times 0 times 1 is 0, minus negative 2 times 1 is a negative 2, so minus a negative 2 is plus 2. And the value there then is negative 8 minus 3 is a negative 11, times 1 is still just negative 11, 0 plus 2 is 2, 2 times 6 is 12, so plus 12, or just positive 1. So the determinant of A, the determinant of this matrix here, is a positive 1. And notice how we started with a 3 by 3, and we broke it down into 2 by 2 determinants. And the same thing would be true if we started with a 4 by 4. We would break that 4 by 4 down into 3 by 3s, and then break each 3 by 3 down into 2 by 2s. Now the next thing we want to do is talk about one easier way that we have to calculate determinants depending on the matrix that we're starting with. So for instance, with this matrix B, we've got a 4 by 4 matrix so we can find the determinant. But what we want to say now is that we don't always have to work across the top row. Remember the last determinant we did, the 3 by 3 for the matrix A, we worked across the top row. But you can work along any row or any column that you want to use that row or that column as kind of your coefficients on those lower level determinants. And the reason that that's helpful is because if you have a row or a column with a lot of zeros in that row or column, then that's a great row or column to use because you'll end up canceling out a lot of determinants. You'll save a lot of calculation. So this is a big matrix here, but notice that the third row includes 2 zeros. So we can work along that third row and calculate the determinant. When we do, we'll start with that first entry. So again, we'll kind of box these out. So we'll start with this first entry, the 0. Then we completely ignore the column and the row. And so the 3 by 3 determinant we're going to pair with this is this determinant here. So if we were going to write this out, we would say that we have 0, and we'll come back to our checkerboard pattern signs in a second. So we would have 0 multiplied here by 3, 1, 4, 1, 7, 2, 2, 1, 1. Now if I look at the second value in that same third row, I'm going to have, again, this 0, and then I ignore everything in this same column and same row. So I'm going to box everything that's not in the row or column with this 0. So that's all of this right here. So when I do that, when I write out that determinant, I have 0 as my coefficient, so 0. And then I write everything in the same order that's already situated in. So negative 2, 1, 4, just go straight across. 1, 7, 2, and then negative 3, 1, 1. Then I want to keep going across the third row. So my next one here is going to be this negative 1. So when I box that, I have this negative 1, and then I pull everything outside of that row and column. So this, and then this value here. And when I write out that third determinant, I'm going to get negative 1, and then here, negative 2, 3, 4, 1, 1, 2, negative 3, 2, 1. And then finally, my last value in that row is this 2. And so then I'm going to take this and this. And so then my final determinant will be the positive 2. And then here, negative 2, 3, 1, 1, 1, 7. And then negative 3, 2, 1. So now we have all 4 determinants. We have to go back to our checkerboard pattern to make sure that we get these signs correct. So how do we do that without writing out the checkerboard pattern? Well, all I have to do is remember that I start with a plus sign in my upper left-hand corner. So I just go plus, and then I count down to the 1 here, minus, and then to the 0 is a plus again. So this is a plus sign, and working across this row, I know my signs always alternate. So starting with a plus, I go plus, minus, plus, minus. So plus, minus, plus, minus. And now I have everything I need to keep going. And notice the benefit of us working across the third row. What would otherwise have been a really tedious problem simplifies tremendously because this 0 multiple outside the determinant is just going to wipe away this entire determinant here and this entire determinant here. So we can actually go ahead and get rid of all of this because it's going to just go to 0. And then here, if we actually bring this up here, notice that this coefficient out in front of this first determinant is just a negative 1. So we can just go ahead and get rid of this here and then have a negative out in front of this determinant. So this is what we have so far for the determinant of B. And now at this point, you could, with these 3x3 determinants, again, work along any row or column that you wanted to. We don't have any zeros left, so there's not going to be a huge benefit of picking one row or column over another. But just for the practice, let's go ahead and find the value of this first 3x3 determinant by working along the second row, this 1, 1, 2 row. So if we write this out, we're going to have this negative sign out in front here, and then let's just put a big bracket to remember to apply this negative sign. This is not going to be a matrix bracket. This is just to remind us to multiply this negative sign across everything. So if we start with the 1 here, we're going to have 1, and then multiplied by the determinant 3, 4, 2, 1. So 3, 4, 2, 1. And then working across the second row, we'll use this 1 here. So 1. And then that's going to be negative 2, 4, negative 3, and 1, the corners. Negative 2, 4, negative 3, and 1. And then the last one is this 2 right here. So 2. And then negative 2, 3, negative 3, and 2. Negative 2, 3, negative 3, and 2. And then we need our signs. So across the second row here, I would start with the negative 2 with a positive sign. I go down 1 to the 1 here and I get a negative sign. So I need negative, positive, negative. So negative, positive, negative. And I've broken down my first determinant and I still have this negative sign multiplied out in front. So let's just go ahead and simplify all of this first before tackling this second one here. So I'm going to get negative, and then here, negative 1, and then 3 times 1 is 3, 4 times 2 is 8, 3 minus 8 is a negative 5, and then we'll say plus 1 times, negative 2 times 1 is a negative 2, 4 times 3 is a negative 12, negative 2 minus a negative 12 is negative 2 plus 12, or 10, and then minus 2, negative 2 times 2 is a negative 4, 3 times a negative 3 is a negative 9, negative 4 minus a negative 9 is negative 4 plus 9, or 5. So here we get positive 5, plus 10, minus 10. Our plus 10 and minus 10 cancel. We're just left with 5, but we have this negative sign out in front. So this whole first determinant is going to simplify down to negative 5. So let's go ahead and replace this determinant with the value we just found. We got negative 5. So we'll go ahead and get rid of all of this and then all of this here. Remember, we already included that negative sign. So we'll get rid of that. And this will be negative 5 and then minus 2 times this determinant. So looking at this second determinant here, Let's work along the third column to mix it up here and do a column. So we'll have the 1, 7, and 1 as coefficients. This time we'll ignore the -2. We'll just work on calculating the determinant itself. So we'll have 1, and then for the 2 by 2 determinant, 1, 1, -3, 2. So 1, 1, -3, 2. And then we have our 7, which is going to be -2, 3, -3, 2. So -2, 3, -3, 2. And then the last 1 in the third column, and that'll be -2, 3, 1, 1. So -2, 3, 1, 1. And then we need our signs. So again, starting in the upper left-hand corner with a positive sign, we would go positive, negative, positive. That 1 is a positive. So our pattern is going to be positive, negative, positive down that third column. So positive, negative, positive. And then I can calculate here. So I'll get 1 times 2 is 2. 1 times -3 is -3. 2 minus a -3, or 2 plus 3 is 5. Minus 7, we'll get -2 times 2 is a -4. 3 times a -3 is a -9. -4 minus a -9 is -4 plus 9, or 5. And then plus 1 times -2 times 1 is a -2. 3 times 1 is a 3. -2 minus 3 is a -5. So we'll get 5 minus 35 minus 5. The positive 5 and the -5 will cancel, and we'll be left with a -35. So again, if we get rid of all of this, we know we have a -35 value. That was the value of this determinant here. So we can go ahead and say -35. So then our determinant for B is equal to -5 plus 70, or positive 65. And that is the determinant of B, which we were able to find much more quickly by working first along this third row. The last thing we want to talk about is just a neat little trick for calculating the determinant of a 3 by 3 matrix. It's called the rule of Saris, and it's really simple, but it only works for 3 by 3 determinants. So let's say that instead of this matrix B here, we just take the top 3 by 3 value. So let's say we need to find this determinant here, -2, 3, 1, 1, 1, 7, and 0, 0, -1. The rule of Saris tells us that we can go ahead and take the first two columns and augment them onto the right side of the matrix. So we take this first column, -2, 1, 0, -2, 1, 0, and augment it onto the right-hand side, and then the 3, 1, 0, so 3, 1, 0. Once we have this, we look at the diagonals of this result that we have, starting with the upper left-hand corner. So if we kind of look at this diagonal here of -2, 1, -1, we're going to take that. We're going to take 3, 7, and 0, and we're going to take 1, 1, and 0. So we're going to grab all three of these, and we're going to multiply these values together. So we're going to say -2, 1, and -1 is that first diagonal. Then we're going to add. So we're going to say plus 3 times 7 times 0 from the second diagonal, plus 1 times 1 times 0 from the third diagonal. Then we work the other way, starting in the upper right-hand corner with this 3, and we take our diagonals the other way. So we say this diagonal here with the 3, 1, -1, and then we take -2, 7, and 0, and then we take 1, 1, and 0. And just like these values, we multiply those, but this time we're going to subtract them. So we'll take the 3, 1, -1, so 3, 1, -1, but we're going to subtract that out of the result. We take our -2, our 7, and our 0, and we're going to subtract that out. And we take our 1, 1, 0, and we're going to subtract that out. So if we do the math here, we'll have -2 times 1 times a -1 is a +2. So over on this side, we get a +2. Notice that we have these zeros here, so they're going to cancel out, but we'll just say +0, +0. That takes care of all of these values that get added in. And then we're going to subtract out each of these. So we have 3 times 1 times a -1. That's a -3. Well, we're going to subtract out a -3. Then we have 0 here and 0 here. So we would just say -0 and -0. The point is, whichever value we get over here, We're subtracting this value, subtracting this value, subtracting this value after we've added over here. And so the result then is just 2 minus a negative 3 or 2 plus 3, which is going to be 5. So the determinant over here is 5, which we were able to find using rule of Saros. So those are just some different rules you can use, some different techniques you can use for finding the determinant of any square matrix.